Hi and welcome to this video where we're going to be looking at the Circle Revision Worksheet, which contained two different mock questions. The first was the 2017 DEB mock. It was from paper 2, it was a section A, so 25 mark question. And the second one is from the 2014 DEB mock. So both of these have some very interesting elements, which can be very good if you're revising the circle. So our first question. The circle S, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0, touches the y-axis at the point A, which is 0, 2. So this point here, and I'm going to write in beside it, is 0, minus 2. Write down the value of f and hence show that c is equal to 4. So the first thing I'm going to do is I'm going to put my center point into this circle. And that center point is given as minus g minus f. Now, because of the way that this y-axis is a tangent to the circle, we can draw a line from the center to A and it will be at right angles to this tangent. That means that our center point, we're going to be able to use the y value of A to get the y value of our center point. So straight away, we know minus f is going to be minus 2, therefore f equals 2. So straight away from our little picture here on the right, we can pull out f equals 2. So then it says, hence show that c equals 4. So we're going to work with the point A, which is 0, minus 2. And we're going to sub into our equation of the circle. We know that that point is on the circle, so when I sub in, the equation should be balanced. 0 squared plus minus 2 squared plus 2g times 0 plus 2f, which is now 2 times minus 2, plus c equals 0. Anything with a 0 disappears. We get 4 minus 8 plus c equals 0. We get minus 4 plus c equals 0. Therefore c equals 4, which is exactly what they asked us to do. So part B. The center of S lies in the third quadrant, and S makes a chord of length 4 root 3 on the x-axis. Find the value of g and hence write down the equation of S. So we now know that these 2 points here create a chord of length 4 root 3. Now my center point is here. One of our circle theorems states that when I draw a radius perpendicularly through a chord, it bisects it, which means it cuts it in half. So I now have 2 root 3 and 2 root 3. I have a little right angle triangle here, and I also know the height of this triangle because remember that point, this point A? This was given as 0 minus 2. So this height here will be equal to 2. So what we actually have is a right angle triangle with 2 root 3 here and 2, and we're going to work out the length of the radius. So we're going to use Pythagoras. So when we use Pythagoras, C is always the hypotenuse. The other two sides, it doesn't matter which one is A and which one is B. So c squared equals a squared plus b squared. C squared is equal to 2 squared plus 2 root 3 squared. C squared is equal to 4 plus 12, so 4 times 3. So c squared is equal to 16, so c is equal to 4. So that is my radius. So my radius equals 4. So what we can do at this point is we can go to our page 19 in our log tables, and we know C, we know a lot of information. We can work through it there. However, if we go back to our actual diagram, we can see because we have the y-axis as a tangent, we know that the distance from the y-axis to the center point is going to be r. So I'm going to show that on the diagram here in red. So that there is r. So that actually tells me where on the x-axis that center point will lie. So here we've got minus g will be minus f. Sorry, minus g will be minus 4 because it is on the negative sense of the x-axis. Therefore, g equals 4. So now I can go and write the equation of the circle. So they gave us the general equation. If they didn't give us the general equation, we can find it on page 19 of our log tables. Plus 2gx plus 2fy plus c equals 0. Instead of using this one, we would be better off, because we know g, f and the radius, we would actually be better off to work with the one that's given as x minus h squared plus y minus k squared equals r squared, given that is the center. So my center point here is minus g minus f, so minus 4 minus 2, so that is actually hk. So we get x minus minus 4, so that's plus 4 squared, plus y minus 2, so plus 2 squared equals 4 squared, and you can multiply that out then if you want. X squared plus 8x plus 16 plus y squared plus 4y plus 4 equals 16. 16's cancel and we get x squared plus y squared plus 8x plus 4y plus 4 equals 0. So we could have worked out our c in other ways, but it was just as easy to work through with our hk formula here. So part C is find the equations of the two tangents from the origin to S. So the first one we actually already know. We know that the y-axis is a tangent. So all we need to do to get that first equation is to write the y-axis as an equation. It is a vertical line, which means that it's a constant, and all of our vertical lines are written as x equals and then the value they go through. So this is going to be x equals 0, and that's the first equation of a tangent that goes from the origin to S. So the second tangent will look something like this. It'll go through our 0, 0, and it will touch the circle. So what we're going to do is we're going to take the point where the tangent touches the circle, and we take the center point, and if we connect these 2 points, we know that that line is perpendicular to our tangent. So to work for the second equation, we're going to work with y minus y1 equals m bracket x minus x1, or you can use y equals mx plus c. Usually we're dealing with this equation. Because we're dealing with the origin, either will work. We have y minus 0, because I know this tangent goes through the point 0, 0. We have m, the slope that we don't know, x minus 0, so the equation is y equals mx. So now what we need to be able to do is figure out that slope, and we'll know the equation. Going back to the radius which we drew from the center to the point where the tangent touches the circle, we know that that distance there should be equal to the radius. We know that the radius is equal to 4. So if we work with this equation, so I'm going to write in the form mx minus y plus 0 equals 0, because we're going to work with the perpendicular distance formula, and it is given as ax plus by plus c equals 0. The point that we're working with is going to be our center point, so we worked that through before. It's minus g minus f, so from earlier in the question that was minus 4 minus 2. That's x1, y1. Our formula is given on the very top of page 19, and it is a x1 plus b y1 plus c, and that's all in absolute value lines, all over the square root of m squared plus minus 1 squared, and that should equal 4. So that should equal the radius. So working with this, we're going to be able to solve for m, and we're going to be able to work out the slope and then in turn the equation. So let's tidy this up a bit. We get minus 4m plus 2, and that should be a 0, all over the square root of m squared plus 1, and that equals 4. I'm going to multiply across by the denominator. Minus 4m plus 2 equals 4 square root of m squared plus 1. So two things that we have here, absolute value signs and a square root. So we're going to get rid of both of them by squaring both sides. There is other ways to deal with the absolute value or modulus signs, but here, because we have the square root as well, we might as well just square it out. So a really common mistake that students make, if I'm squaring out the absolute value signs, I do have to square what's in them. All that the squaring does is make sure that it's positive, so I no longer need them. So we get 16m squared minus 16m plus 4 equals 16, and here the square root and the square cancel, so that's m squared plus 1. So we get 16m squared minus 16m plus 4 equals 16m squared plus 16. 16m squared on both sides cancel, so I have a minus 16m equals 16 minus 4 is 12. M is equal to 12 or minus 16, and that simplifies into minus 3 over 4. So looking at our actual diagram, it makes sense that that slope would be negative. So going back to the equation of our tangent, it's going to be y equals minus 3 over 4x, and that can be written as 4y equals minus 3x, or if you prefer 3x plus 4y equals 0. So question 2, C1 is this circle here, and L is the line 2x minus y plus 5 equals 0. C1 and L intersect at the point PQ. Write down the center and radius length of C1. So we're going to use the general formula of a circle, which is found on page 19 of our log tables. X squared plus y squared plus 2gx plus 2fy plus c equals 0. So our center is given on that page. It's minus g minus f. So from up here, we get g is minus 1, so therefore minus g is 1. And we can get f is minus 2, therefore minus f is 2. So then the radius here will be given as the square root of g squared plus f squared minus c, which is equal to minus 1 squared plus minus 2 squared plus, so it's minus 20, that'll give me a plus 20. And working that through, we get the square root of 1 plus 4 is 5, square root of 25, which is our 5. So we have our center and our radius. Find the perpendicular distance from the center C1 to the line L in third form. So our center is 1, 2. Our line is 2x minus y plus 5 equals 0. I'm going to label our point x1, y1. Our line is ax plus by plus c equals 0. Our formula, which is on the top of page 19, is ax1 plus by1 plus c, all in absolute value signs, square root of a squared plus b squared. They want it in third form. So our bottom line here will be square root of 5. We'll leave that as is. And here we get 2 minus 2 plus 5. So we get the absolute value of 5 over root 5. The absolute value of 5 is 5 because it has to be positive. You can put that into your calculator, but we're going to rationalize the denominator by multiplying the whole fraction by root 5 over root 5. That gives me 5 root 5 over 5, and the 5's cancel, and I'm left with root 5. So that is the perpendicular distance from the center C1, center of C1 to line L. So now it says, hence or otherwise find PQ in third form. So we know that this line here, it cuts it at the points PQ. We can of course work out PQ and find the distance, but it does say hence or otherwise. So we need to work with what we have, and here's my center point 1, 2. So my center point 1, 2. Think of the things that we've just worked out. We've just worked out that that distance there is root 5. This distance here is our radius, which is 5. We know that if we draw a line perpendicularly from the center to a chord, it will bisect it. So that means whatever length we have here, we simply need to double it to get the length of PQ. So I'm going to sketch this out in a nicer way so we can work with it. So there's root 5, there's 5, and I'm basically trying to find this length here. So I'm going to use Pythagoras. C is always the hypotenuse, doesn't matter where A and B is. C squared equals A squared plus B squared. So I get 5 squared is equal to the square root of 5 squared plus x squared. So 25 equals 5 plus x squared. X squared is equal to 20. X is equal to the square root of 20. So x is equal to 2 root 5. So then the length from PQ is equal to x plus x, which is 2x, which is 2 times 2 root 5, which is 4 root 5. So like I said, you can work out the points PQ, but there's absolutely no need. The word hence there is giving us the hint that we've actually worked out most of the information we need to figure out PQ. So part C says PQ is the diameter of the circle C2. Find the equation of C2. Now, I've just pulled in the extra information from the top of the question just so we have it. But to work out the equation of a circle, we need two things. We need to know the length of the radius, and we need to know the center. Now, I do know the length of the radius because if PQ is the diameter, that was 4 root 5, then the radius here will be half of that, which is 2 root 5. That was actually the length of x, which we worked out in part B. We are trying to find the center. Now, the center is actually going to be the midpoint of PQ, but we actually don't know P and Q. So what we need to work out is, are the points P and Q, and then we're able to work out the midpoint. So we know that it's where this circle, x squared plus y squared minus 2x minus 4y minus 20 equals 0. It's where that intersects with this line here. So what we have now is a linear, non-linear simultaneous equations. So we're going to label it 1 and 2. We always sub our linear into our nonlinear. So nonlinear. So we're going to take equation 2 and we're going to isolate one of the terms. So the easiest term to isolate is y, which is 2x plus 5. And then we're going to sub y into the nonlinear. So we get x squared plus 2x plus 5 squared minus 2x minus 4 times 2x plus 5 minus 20 equals 0. X squared plus 4x squared plus 20x plus 25 minus 2x minus 8x minus 20 minus 20 equals 0. Tidy up what we can. There's our x squareds, x, and an x. So we get 5x squared minus 10 plus 10x and minus 40 plus 25 minus 15 equals 0. To tidy that up, I'm going to divide across by 5. 2x minus 3 equals 0. And we're going to solve that. So we have x squared plus 2x minus 3 equals 0. You can use your guide number. You're going to end up with x plus 3, x minus 1, which gives us x equals minus 3 and x equals 1. We're going to sub those back in. So when x equals minus 3, go back to equation 2. Y is equal to 2 times minus 3 plus 5 minus 6 plus 5 minus 1. So my point here is minus 3 minus 1. When x equals 1, going back to that equation, y equals 2 times 1 plus 5, so that's 7. So that's the point 17. So we don't know which one is P, which one is Q. Doesn't really matter. And we're going to get the midpoint of PQ. And that's going to be labeling x1, y1, x2, y2. Midpoint formula, minus 3 plus 1 over 2, minus 1 plus 7 over 2. And that gives us minus 1 and 3. So my center is minus 1, 3. So now all that we've left to do is to put this in to an actual equation. I'm going to put it up here so we can keep the rest of our workings. So we're going to have x minus h, that's plus 1 squared, plus y minus 3 squared equals 2 root 5 squared. You can multiply that out if you like. X squared plus 2x plus 1 plus y squared minus 6x plus 9. 4 by 5 equals 20. Cleaning that up, x squared plus y squared plus 2x minus 6y. Apologies, I think accidentally I've stuck an x in there, so that's y. And we have 10 minus 20 minus 10 equals 0, and that is our final answer here, the equation of circle C2.